look at multiplication. And just like with the last few videos, we'll restrict ourselves to whole numbers for now. Multiplication can be thought of in different ways. One idea is the idea of repeated addition. In this case, a problem like 3 times 4 means 4 plus 4 plus 4. When we're thinking about multiplication in this manner, the first number in the multiplication problem tells you how many times you will add the second number to itself. So 3 times 4 means adding 4, a total of 3 times. Another way is to think of it using rectangular arrays. In this case, 3 times 4 would mean we need to build a rectangle with 3 rows and 4 columns, such as this one here. And in this case, we can then count the number of smaller squares inside of this array to see that the result would be 12. In a multiplication problem, the numbers that are being multiplied together are known as factors. So in this case, 3 and 4 would be the factors of this problem. The result is known as the product. So the 12 would be the product. There are also multiple ways to denote multiplication. In this case, I was using an X, which is our common multiplication symbol, but sometimes we use a dot or parentheses. So we could write it as 3x4, 3.4, 3 parentheses 4, or parentheses 3 parentheses 4, like these 4 ways here. There is an important property of multiplication related to multiplying by 1. In particular, multiplying any number by 1 just gives that number. In symbols, we have that 1 times a is equal to a, or a times 1 is equal to a. As a more concrete example, 1 times 2 is equal to 2, and 2 times 1 is equal to 2. Because of this, the number 1 is known as the multiplicative identity. Let's now look at how to multiply larger numbers. And I'm going to start with what's known as the partial products algorithm. In this algorithm, we're going to multiply each place value of one number by each place value of the second number and add the results. So we'll start with the 6 and the 2. 6 times 2 is 12. So we write down the number 12. We're still going to stick with the 1s in the second number, so the 2 in the second number, but we're going to move to the 5 in the first number. Since this is really a 50, what we're really doing is 50 times 2. And 50 times 2 is 100. Since I've now multiplied each place value in the first number by the 1's place in the second number, I'm going to move to the 10's place. 40. 40 times 6 is 240. And then finally, 40 times 50 is 2,000. Now that we have multiplied every place value in the first number by every place value in the second number, we can just add these numbers, 12 plus 100 plus 240 plus 2,000. When we do, we get our final result of 2,352. As another example, let's consider 69 times 46. We start with the 1's places. 9 times 6 is 54. I then do the 10's place in the first number by the 1's place in the second number. So 60 times 6, that's 360. Moving on to the 10's place of the second number, 9 times 40 is 360. Finally, 60 times 40 is 2,400. We then add these numbers, 54 plus 360 plus 360 plus 2,400. When we do, we get our final result of 3,174. Multiplying with this algorithm is effective, but it's not necessarily efficient. To make it more efficient, we want to use our standard multiplication algorithm. When using this algorithm, we actually combine some of the steps. These two numbers here, we do the multiplication and addition in a single step, and then the same thing with these two. We do our multiplications and our additions in a single step. To demonstrate this algorithm, consider 86 times 59. Just like before, we start with the ones place. 6 times 9 is 54. So in this case, we write down the 4 and then regroup the 5, the 50 part of 54. When we do that, we write the 4 in the ones place and then move the 5 to the top. We then multiply 9 times 80. That is 720. And then we add the 50 that we regrouped since we're doing this multiplication and addition in a single step. So 720 plus the 50 that we regrouped is 770. That gives us 774. Now we're going to move to our 50. 50 times 6 is 300. We write down both the tens and the ones place there and regroup the hundreds this time. We can also cross out the 5 that was regrouped earlier since we're done with that one and we don't want to confuse ourselves. Next, we have 50 times 80, which is 4,000, plus the 300 that we regrouped gives me 4,300. Combined with our 00 we had from before, we have 4,300. Finally, we add these two numbers. When we do, we get our final solution of 5,074.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.